My name is Blake Hembree. I'm a senior mechanical engineering student here at the Georgia Institute of Technology. This presentation is for my design and manufacturing class. It's our first project of the year. It is titled The Engineer's Edge: 5 Principles to Build Smarter, Faster, and Better. I believe some of the 5 key ideas I'll share here today will really give any engineer an edge within design and manufacturing. These principles and ideas I'm going to share just aren't just theories, right? They're really tools that can help us kind of sharpen our bank of tools, be able to build faster and solve problems before they happen. This is submitted to my professor, Dr. Hassan Rashidi. This is for spring 2025. So hopping right into the 4 topics I'm going to go over today. The first is the Pareto principle, um, also known as the 80-20 principle, um, which we'll go into momentarily. The second is lean manufacturing. If you're familiar with Toyota or really any other automotive industry, this is something that's heavily prevalent there about minimizing waste. The third is rapid prototyping. This has to do with 3D printers, additive manufacturing, really any tools that can help you really speed up the design process. The fourth is DFMA, design for manufacturing and assembly. This one's kind of self-explanatory by the name. The fifth one is FMEA, failure modes and effects analysis. For all those who took ME 2110, this really kind of lets you plan for the worst case and focus on which modes, which failures are of the highest severity. So jumping right into the Pareto principle, also known as the 80-20 rule. Uh, kind of overview or summary of this is that 80% of the outcomes come from 20% of the inputs. In engineering, this really helps you focus on the vital few, not the trivial many. It really changed the way I view things. Instead of doing everything, right, I take a step back and I ask, what 20% of work can really give me this 80% of results? Whether it's within design iterations, troubleshooting a process, it really helps you, stay narrow and keep focused on the most important things and what really matters. It can really reduce production delays, simplify product problems. I kind of have a case study. For example, this past summer I worked at Marmon Keystone. They're a metal bar and tube manufacturer. They kind of took this principle head on and applied it within their facility. So within their inventory, they had a lot of these metal tubes, ones that weren't getting cut at a high frequency, located close to the cut cells. So the machinery such as like saws and lasers, and then some of the other fast moving stuff, things that got cut like daily or multiple times a week, was located further away, right? So they took this 20%, this fast moving stock that really was giving them the most revenue, that 80% of outcomes, and chose to restructure the inventory in like a sort of a yellow or red, yellow, green setting so that fast moving stock was located closer to the cut cells, really reducing production delays and basically just focusing on what truly mattered, that 80%. The next is lean manufacturing. This originated with Toyota's production system. It's basically a philosophy focused on minimizing waste while maximizing value for the customer. Um, it's really about kind of taking a step back and looking at the process or your flow from a business standpoint, and just making sure that value is always being added, right? It's rooted within continuous improvement, respect for people, and just-in-time production, which I really think is a smart idea. Just-in-time production reduces like the inventory waste you have. So instead of keeping tons of stock inventory within your warehouse, you get an order from your supplier whenever a customer places an order. So you don't have that long and O&E material, outdated material doesn't really boil up quicker. You also have 5S systems, which really helps to standardize the workplace. It's really a great organization tool for efficiency and safety. There's also value stream maps, which allows you to visualize product flow, also like highlighting the bottlenecks kind of within your flow. A really cool case study that I saw or found was from Toyota, where they revolutionized, uh, they're the kind of fathers of lean, but what they did, they were able to reduce the time to change a die press from 2 hours to under 10 minutes using SMED, single minute exchange of dies. This saved millions in downtimes and really enabled a smaller batch production. So you can see that this, lean manufacturing is really an applicable tool that can, reap some strong benefits. The next is rapid prototyping. So this is the use of 3D printers, metal printers, additive manufacturing. What it does is uh, allows you to convert digital design into physical parts really quickly, speeds up testing, encourages design iteration, which I think is really important, right? And reduces tooling cost. I feel like prior to rapid prototyping, people were really focused on um, making sure that first design was perfect, which I don't think is a great way to approach it. What rapid prototyping does is let you fail fast, which I think is a really good thing. You can go from a CAD part or from a CAD to a part overnight. You can test it, you can tweak it, you can repeat it. You can keep this process ongoing, which is really good within design. Helps engineers kind of catch flaws before they jump right into full-scale production. Another internship I had before Marmot Keystone was with Z1 Motorsports, an aftermarket car part manufacturer, and their print lab was full of 3D printers, right? And these things were constantly getting run, creating, test eccentric bolt kits, making, test rotors, all these different types of parts were being tested and printed, with these 3D printers. Fitment was checked, alignment, making sure tolerance sort of fit, so that when they did, place an actual fabricated prototype, they had a good understanding that their design was already, able to work at that stage. The next is DFMA, Design for Manufacturing and Assembly. Um, DFMEA kind of flips your perspective, right? From how cool something looks, how aesthetically pleasing it is, to how easily it can be made and put together. It really forces us to design with production in mind and not just perfection, which I think is really important. You're designing parts and assemblies to make them manufacturable and as simple and cost effective as possible. If we look at this bottom right image, it shows an initial design and then the redesign of this same part after DFMA was ran on it. I mean, you see how multiple parts are combined, especially ones that share, certain features like these brackets are reduced. This really can also help for the usability of it. So, think about the car parts or automotive industry where a lot of them are done by mechanics or even the consumer themselves install their pieces. You get these kits that have lower number of parts. It's much easier to install for the customer. Now going on to the fifth one, FMEA, failure modes and effects analysis. This one basically plans for the worst case. So you're basically playing devil's advocate on purpose, right? You're asking, how could this fail? And what would happen if it did fail? It's really all about, thinking ahead and make sure that your design and your products are bulletproof. Not all industries need like a certain strictness with this, but really ones like automotive, aerospace, and healthcare, I feel like it's of the greatest importance. It really allows you to prevent problems before they happen. Really improve reliability. Anyone that took ME 2110 knows it kind of had this chart, right, and then it gives you a risk priority number which combines severity, occurrence, and detection, and scores it to like quantify the risk. Can really allow you to allocate your engineering resources efficiently so you're not spending too much time on these modes that are of less risk, and then you can really prioritize the ones that are of the utmost severity. If we look here at the bottom right-hand image, this is of Apollo 13's oxygen tank that failed. So it was in orbit and actually failed and blew up. If you've seen the movie, I'm sure you know what I'm referring to. But the rigorous analysis of NASA and being able to test all of their parts and have single failure plans before they sent the spacecraft up is what really saved the crew. So you can almost think that FMEA engineering really helped save that engineering crew. Final thoughts. These topics kind of work like gears. 80/20 and lean shape how I think. Rapid prototyping, can help you build quickly. DFMEA makes it buildable, and then FMEA keeps it reliable. So they're, comprehensive and working together system for smart engineering. Thank you so much for watching. I think these 5 principles will really change how I approach engineering problems, and I hope they did for you as well. Whether you're designing rockets or wristwatches, these tools can really help you build better. Thank you.